Okay, those of you that still have the questions here. So chapters 4, 5, and 6, that's trigonometry. Something some of you guys may want to do next year and some not. We're going to skip those chapters. We're jumping into chapter 7, and we're going to take some time to put a few things you guys learned in Algebra 1 together into one thing. So first things first, do you guys remember systems of equations? Of course I do. Camille remembers it. That's perfect. That's when you had two equations. You had x's and y's in both of them, and you had to solve. So see if this guy remembers here. Something called substitution method, elimination method.
Oh boy, I know what you're talking about, but I don't know how to do it.
Okay.
I remember what you're talking about. I remember being terrible at it.
Okay.
Like not remembering anything.
Yeah. Okay, that's fine. We will. So what we're gonna do is we're gonna take three things actually. We're gonna take that whole time of systems of equations. So we're always gonna have at least two equations to deal with. Second piece is we're gonna do not just linear, but also x to the second, x to the third equations. So in Algebra 1, you guys only did linear equations. It was only x to the 1 power, y to the 1 power. We're going to go off into nonlinear. And thirdly is we're going to do this in inequalities as well. So what happens if you push in a equals less than or equal sign, greater than equal sign? So three things coming together. You guys we're taught them separately in Algebra 1. We're kind of just fusing them together into one thing in Algebra 2. So let's go. So 7.1. Oh, I started on this side, then I finished it up. Okay, so if you want to write it down, 7.1, it's called linear and nonlinear systems of equations.
You know what everything is coming.
Gotcha, okay. Yeah, we should go. Can I go back real quick here? So in your mind, kind of just setting up your mind here. So we're going to look at linear and nonlinear systems. Then we'll look at something called two variable linear systems, and then how about multiple variables? Just throw in whatever we like as variables.
No.
Then we have something called partial fractions. What are those? Okay, and then we jump into systems of inequalities. So what happens if you have to, remember how we graphed it in Algebra 1 and we sketched it? Remember that? We sort of sketched one side of it. Okay, and then maybe hopefully we can touch on linear programming. And so that is part of it right there. That's one of the, we'll see if we get there or not here. Hey.
Are we ever going to come to a point in math where we get full circle and we just are working with numbers?
No, sorry, that does not happen. In fact,
one day at the end of the year where we're just doing something.
Like 2 + 2?
No, I don't care how big the numbers are. Just numbers.
Just numbers.
From what I know,
No variables.
They did a problem that literally had no numbers. Is that correct? I remember Nicholas telling me about how painful that was. About how there was a problem with no numbers whatsoever.
Yeah, let's see. To go the opposite way of Abe, we do trigonometry, we do calculus. There's a whole calculus sequence, right? And then we do a little statistics. And after that, if you kind of think about it, there's a few other number courses, but after that, you get theory courses. So the only numbers you see are technically your page numbers. It is all variables. It is all theory. It's all, hey, if A minus B is equal to C,
That's
and then if this and this, then what happens here?
Are those required courses?
Not for high school. To become a math major, yes.
I guess I'm not going to be a math major.
Yeah, I guess that's not for you. That's okay. Let's jam.
What's the point of learning this math if we're never going to use it one day?
No, but you
Sure.
Oh, it's the universal.
Sure.
No, we're not.
I would hurt.
Yeah.
All I need is like basic addition, which I can't do.
This is why we have math class.
Exactly. Well, how am I going to learn basic addition if I can't even do this? I gotta learn basic addition. And then
Flip those around. How are you going to do this if you can't even do basic addition?
Let me jump to maybe this will be interesting. This is just application of this stuff here. So I should have just put this one on top. I put business on top because that's the one that comes out the most. Whenever you talk about break-even point, that's when cost equal revenue. You're talking about two equations. You have a cost equation for your business. You have a revenue equation, right? The break-even point is when those two are the same or they equal each other. A supply and demand
Did a
curve.
bunch of work and got nothing out of it.
Yes, correct.
That is useful.
In fact, I have a acquaintance. He owns a gym in Fresno, and he said, roughly speaking, by the time everything's said and done, it's about $50,000 to run a gym on a monthly basis. So if in order you got to make it $50,000 in revenue, right, just to break even for the month. And there's been plenty of months where you didn't break even, right? Sometimes you make more, right? But this is the whole concept of all these costs. So think about running a gym, right? You have the lease on the building, that's one. And then if you owe any money on the equipment itself, that's another one. Then you have to pay employees. Then you got to pay health insurance for the employees, right? You have to, yeah, you can make one, absolutely, you can make one. That's the whole point, yeah. So you have all these different cost equations on this side, right? Then you have a revenue on this side, and then also part of the one, then you had to think about equations that influence the other, like marketing, right? If you have a marketing program, did you get more people into the gym? Because that actually has a correlation, as opposed to your lease on the machine. 100 people come in or 0 people come in, you still owe the lease on the machine, right? So there's that little fineness of cost that you got to be careful of. But whenever you have,
Simple stuff, or like selling sweatshirts or shirts, we figure out how much money it costs to make a gift card, see how much money we pay.
That doesn't require a formula, that's just addition and subtraction.
Formula.
so with,
Cost minus whatever you sell it for.
This is money we pay.
Idiot plus idiot equals stupid.
Not important, sorry.
no, that's cool. Yeah, I'm just thinking of doing that. You have raw material costs as well that play into it, because if you order 10 shirts from a company, they're going to charge you a certain amount. If you order 100 shirts, they'll probably charge you less. So your cost function just went down by ordering more. You got to just make sure that you can sell that amount to recoup that. So right? There's that little cost there as well. And so supply and demand curves. Another one, a supply curve is how much inventory you have. Demand is how much inventory there is in the market for it. And then you usually do a price point for that. This one, let's say you have multiple apartment buildings. Maybe that would be a good one, right? And so economy is a certain level. So because of that, there's only certain people that want to rent an apartment. And so you got to do a price point for that. Investments, decision-making. Anytime you have a decision-making, things based upon 2 or more factors. So let's say weather and temperature, those 2 factors for farmers, they figured out, okay, if that is the case, then what do I do? Maybe a good example would be orange crops. Oranges, they actually need to freeze just a little bit here to sweeten up the flavor. And so have you ever seen those mills next to, you guys have passed an orange field where you have this little, almost like a big fan turbine? What happens with those is they either turn it on or leave it off based upon the weather. If it's too cold, like say it goes under 25 degrees, they actually have to run those turbines because they want to heat up the temperature right at the tree level. Because if you go below 25, then it freezes and then then you ruin your crop. If you're right in between that 32 to 25 degree angle, you're sweetening up the oranges before harvest. So it's an awesome science. So what they do is if the temperature is just getting right at that level, they'll turn them on because you guys have seen this before in temperatures. You have the feel of the weather, right? And the actual weather, right? There's kind of like those 2 concepts there, right? So by spinning the turbines, the atoms actually hit each other and it makes the temperature a little bit warmer right at that level because the atoms are just flowing through the air and they're bumping into each other. I thought that's kind of cool. Anyways, science, when we deal with density, chemistry, when you're mixing things together, this is all about this right here. And sports ratios of certain types of sport, I think we'll do an example problem like that. Balancing a diet, including what you need, right? So anytime you're thinking about two or more items in your mind, you're technically thinking of systems equations. So part of the answer to Camille's process is we deal with numbers right here. In the real world, you don't deal with numbers, you deal with things, right? But you still have this process. How do I keep this and this sort of in check or in balance, right? Because that's what this is, right here. Or how do I come to a solution where these three factors are affecting this? I think that's kind of a cool skill set to have. Again, deal with numbers here. And then as we go through this chapter, maybe you tell me, like in your life, what two things do you sort of keep in thought process, or three things you sort of keep in process, or four? The good chess players, we say they usually are able to keep 7 things in process. And so they can probably guess at what your next move is on the chessboard because they played it so much, right? Up to 7 moves out. And that makes a grand chess player right there, if you can predict your moves. And then you're predicting theirs. Anyways, let's go. Let's begin. So, almost.
I've still got hair.
The second person that
Second person that's brought anything up about my hair. There you go.
So let's jam. Let's go with it. So we are going to review something. We're going to review the substitution method from Algebra 1.
Oh boy.
So on these ones, I really want you guys to connect between the equation, the algebra way of doing it, and the graph. So the homework questions, they all have graphs next to them, or most of them have graphs next to them. The beginning ones do. And then I'm going to leave off the graph afterwards. But let's jam. For example, we'll solve the system by the method of substitution. And then we're going to just check to make sure the graph is correct. So they're graphed right there as well. So x minus y is equal to -4. X plus 2y is equal to 5. And we are going to just practice the method of substitution. Cool. We're good? Let's jam. We're going to take one of those equations right now because they're both linear. It doesn't matter which one it is. We're going to solve for one of those variables. Pick one, solve one. You probably want to pick something that's easy though. So yeah, notice the bottom equation is x plus 2y. You probably don't want to solve for the 2y or the y because we're going to get fractions, right? You got to divide by 2. So forget that. That's not one we want to solve. I could solve and then we want to get rid of negatives as well, at least for the most part. So we have to deal with them. We don't like to. So I'm thinking this. I'm thinking either solving for this x right over here, because it'll just be subtracting 2y from both sides. I'm thinking maybe solving for this x over here, because I'm just going to be adding y to the other side. It doesn't matter. We'll have a pick today. Which one?
The top one.
Top one. Okay.
You picked the wrong one.
Oh, is this the type of problem where you like solve it and then you replace like the x in the other problem?
Oh,
Y minus
now I
4?
remember
Absolutely.
these.
Now I do too.
Okay,
And I
Camille.
hated these.
Camille, no killing today. No killing today. So let's go with adding y to both sides.
When you get y minus 4 and then in the other problem you replace x with y minus 4. Right?
Perfect. So substitution method, solve for one of the variable, and it's always the same process. So Owen, it's solve for the variable. Next, plug in your expression into the other equation. So Abe, you chose the top equation. So we're going to plug x gets substituted. Hey, that's the word substitution comes from. We're going to substitute x as y minus 4. So as we were rewriting this equation, I like to put parentheses because then I know exactly what I substituted afterwards. Just a little extra parentheses there helps. Okay, let's jam. We don't need a parentheses. There's nothing to multiply into. Boom, and perfect. I'm gonna go with Abe, are you okay? Just making sure.
Yeah.
I'm gonna go down the list and bug people now here. So, Maddie, what should we do next? Besides looking at Abe, do whatever he's doing.
I'm like tic-tac-toe on my arm by scratching.
Okay.
Naturally, that's normal.
It works.
No,
He always wins too.
add 4.
Perfect, yeah, we can add 4 to both sides at the same time, probably do this as well. Let's put our y's together. So I got y and 2y make 3y. 4 plus 5 is 9, perfecto. Divide by 3, and I got y equals to 3. Owen, all yours, what do we do next?
Plug in the y back into the original equation that we started with.
Ooh, yes, okay, so we have one of few choices here. Class, Owen says plug back into the original equation that you started with. That is correct.
Good job, Owen.
Also, you can plug into anything that you have already solved for, the substitution step, right?
Yeah.
Because that top equation, x minus y is equal to -4, that's really the same thing as x equals to y
So
minus
when
4.
we plug in the substitution, it's just saving us one step.
Correct, yeah, we plug in the substitution because actually this becomes a pre-algebra problem, right? There's nothing that you need to move across.
Ah,
You just go like this, which becomes this, and done.
Is that always the case? You can plug it into the substitution or the pre-substitution one?
Uh-huh, absolutely. So you can plug into any one of the original equations. You can plug into the bottom equation if you like, but the fastest way is you plug in the one that you already solved for. So final answer, x always goes first, followed by the y. In this case, it is -1, 3. And talk to me. Looking at the graph right there, is the graph confirming our answer?
Whoa, I didn't look at
Yes.
the graph before. I could have just looked at that and solved it. Why did we do all that math?
Okay, so here it is. Look at this.
Well, 'cause that's
It
how
says
we
solve the
get
equation and then look at the graph to make sure they work
But
together.
why wouldn't we just look at the graph first?
Because chances are you don't have the graphs. I can tell you don't read instructions on things.
I don't know what instructions are.
You also don't know whether or not it's like point something above that.
Well, what if he was
You
lying?
can never tell with the graph.
Landon made a good point. Abe made a bad point.
Knowledge is
You just want to use
stupid.
the graph to check yourself.
Well,
Yeah, so you're using the graph to check your answer as opposed to solving the equation. I do want you guys to realize the graph and the algebra connection. That's why I put these homework questions up. Okay, let's jam, a little more difficult. Notice these guys are 2 lines, right? That's the ones this is actually a problem you probably did in algebra right here. And then let's go back before we even go on here. Give me the 3 different possibilities of this stuff. Do you guys remember that in algebra?
1,
So-
2, 3, wait, no,
Three different
-4, 5, 9.
One possibility is that you have one solution. There's an intersection point. What's another possibility of 2 lines graphed?
They never intersect.
parallel.
Yeah.
Parallel.
Perfect. Yeah, parallel lines, they never intersect each other. This is the one that we're going to have no solutions to. Any other choice?
One's perpendicular.
Perpendicular, good job, Charlie. Good. Perpendicular, still we consider that to be one solution. It just hits at
They're
one
on
spot.
top of each other.
Oh, yes.
Yeah,
The one that's on top of each other. So we got this one, and then the other line is right here. We call this infinitely many solutions.
Oh,
IMS.
Wait, what would be an example of that?
We'll get there. We'll get there. as we go
So
through.
we're just trying to find where they cross.
Yeah, the whole point is finding that point right there, but understanding there's 2 other possibilities that could be happening that you don't see.
You can usually tell when there's parallel though, just by looking at the equations.
No solution. This is called infinitely many. Oh, many
She
solutions.
always does, what's your point?
Okay, we're good?
Would we answer IMS in that case?
You could, yeah. All right, let's jam to the next one here. Now, a little more complicated. This one you did not see in Algebra 1 because now you have yourself.
It looks like a
Oh.
straight. No, thank you.
Now you have a linear
I
equation
already
and a
love it.
non-linear.
Wait, so
equation.
Yes.
Oh, that's
So-
why there's 3 points of intersection.
Okay, that's linear and this is non-linear.
Ew.
That's our little problem there.
We saw the linear one.
Good.
Yes, in fact, it's absolutely true. We want to solve for the linear one first because there's a correlation between the y and the x directly to each other. Good. So we take the linear form first. If there's a linear, non-linear, solve it for the variable. Hopefully you don't have fractions in your head or on a piece of paper.
Why would they be in my head? Imagine having math in your head.
I was about to say that, and I knew it.
Okay, now can you substitute?
Yes.
Absolutely. You're gonna have to. So we're gonna rewrite the nonlinear form right here. X squared stays as X squared.
That's x cubed.
Sorry, thank you so much. X cubed minus 2 plus negative 3x plus 2 equal to 0. Not very nice looking.
It looks beautiful.
X cubed. It just becomes x cubed minus 3x.
Yeah, the
The twos cancel.
Oh, cool, okay. Maybe not as bad. Okay, 2's cancel, x
Still
cubed
terrible.
minus
X cubed minus 3x.
Okay,
equals
what's
0.
x?
Oh.
And
No, you're wrong.
X cubed would be
Isn't it 2x?
x.
second,
So x cubed and 3x have to be 2.
x cubed.
Yeah, so they cancel each other out.
Not 1, 2, 3, or 4.
Yeah, it's set equal to 0. What can we do to stuff when things are set equal to 0? It starts with F and ends in actor. Hey, all right.
Tractor.
Be that dumb, guys. Yes, it is.
Starts with F and actor.
I can factor out the x because that's common in both.
I'm sure.
I'm left with x squared minus
second
3.
graders smarter than us.
There are second graders who are geniuses, Camille.
Yeah, have you met
That's
Kind of, not really, but he's also related to you, so it just makes sense.
fair.
Yeah.
Charlie, what do we do next?
Yeah, Charlie. Wow, I feel really loved right now. I just got skipped.
Oh, that's right. Oh, Camille, what do we do next?
Oh, I don't know. So go to Charlie. Unless Charlie's gonna.
Camille was gonna say, we're gonna split this off into
Yep, that's exactly what I was gonna say.
x equals 0 and
X squared
x
minus
3 equals 0. Perfect. This one's solved.
Oh my God, you read my mind.
Shoosh. Okay, next, now it's Charlie. Charlie, what should we do? X equals 0 solve. How about x squared minus 3 is equal to 0? How do we solve that?
It's x
Oh,
plus
yes.
radical 3 times.
Are
x
you
minus
Charlie?
1. No.
So notice that 3 is not a
No.
notice 3 is not a perfect square. If it was a 9, we can factor again and we're all good to go, right? 3 is not a perfect square, so therefore we are going to add 3 to both sides.
I don't think that's enough.
Perfect.
I don't know.
And Landon already has given the answer even before I called on him. So how about x equal to plus or minus the square root of 3, right? We take a square root of both sides. We have to put plus and minus because there's 2 of them. Oh, awesome. That's cool. Okay. We have 3 things to plug back in. And let's see if we get these points. Looks like this point is like right here. There's another point right there. There's another point right here. So let's see if we get pretty close to those, right?
The square roots are, those do look like the square roots are in the right place.
Yeah, anybody got a calculator? What is the square root of 3?
I
As
got
a,
Almost 2.
almost 2? That's right, yeah, it would be almost 2 because square root of 4 would be
It's like
2.
1.144 something. I don't know.
Ooh, that-
1.732.
I was close.
1.7. Okay, yeah, so it should be close. Yeah, it is kind of close to 2. What do you guys say? Do you guys agree? It's about right there?
Yeah.
That's about 1.7-ish. Perfect. Okay, so let's plug in. We're going to get our 3 answers in just a bit. Let's go. So plug in the 0. So if you want to just kind of put this in on the side, 3 times 0 plus 2 equals 2. Our coordinate is 0, 2. Oh, not fun. The answers are actually not even fun. Look at this. This is, let's plug in the positive root 3 plus 2.
Oh, this is not.
Oh, yeah. A little bit more complicated than Algebra 1. So let's see. These guys don't go together. This is just negative 3 root 3 plus 2. Actually, I should write it over here. Negative 3 root 3 plus 2.
I'll calculate that.
Okay.
What is that? Negative 3?
I wanna do it.
Negative 3
radical 3
times the square root of 3, and then add 2 to it.
plus 2. Negative 3.196.
Ooh, hold on. 1, 2, 3. That's about right? That's negative 3-ish. Okay, how do we write the answer? Here it is. Ready, guys? The x coordinate is going to be root 3. The y coordinate is going to be negative 3 root 3, and you may want to stretch this out, plus 2, because we want the exact answer. Are we good? Whew, okay, next one. How about if we plug in a negative? Negative root 3 plus 2 makes, ooh, this is not going to be a positive. This is positive 3 root 3 plus 2. And the coordinate should be negative root 3 and 3 root 3 plus 2. Anybody positive 3 root 3 plus 2 plus 2?
I'm so lost.
Abe, let's get you unlost. Where are you at? Where did I lose you?
You lost them when you just at the beginning of the
No,
day.
no, no, how do we get the coordinates, like? Oh, you just plugged it into the wall, and where did you put? Oh, the equation up there, okay.
Remember the one that we solved for, right? That's a lot easier because I sure don't want to be doing this one, right? And trying to solve stuff.
Oh, yeah.
Okay, anybody, Camille, do you have the approximation to 3 times root 3 plus 2?
If I knew how to use this, then sure, but there's just a lot of buttons.
Okay, maybe I'll have it back there.
I don't know, I can do it on my phone calculator, because that's all I've been doing on my own. and that works
Okay.
Perfectly well.
Dylan, I'm gonna bug you. Do you have a calculator on you or no? Or Tristan, one of the two.
I think I was running on.
Okay.
3 root 3.
Well, just good, Isabel.
7.19.
Awesome. Okay. Let's see, negative 1.7, and that's about 7.1 right there. Yeah, that's about 7.1.
I like them now.
They're
Okay.
butterflies.
So final answers, guys. Final answers is this one, and this one. We good? Okay, a little bit more complicated in algebra 1. Yeah, a little bit. Okay.
Trying to get these down.
Because my parents would know the-
Okay, so then you really want to verify the stuff with the graph. Okay, what do we got here? Got some time here. Let's go with,
I'm just trying to get these down real quick.
sure. Okay, next. How about next where you don't have, none are linear. You got both that are non-linear. Oh, gee, oh,
Can
gee.
we just graph both of them at the same time? I'm gonna do that.
What
And
happened
then I
to us
can
using
trace
like
to the
the
things.
boxes? Those were fun and easy.
I've reached peak intelligence.
No. No.
Can you do non-linear equations?
Oh my God,
Okay,
there's crayons
good, good.
in here?
Just crayons?
Alright, let's, stop being children.
Right there.
Oh, crayons.
Uh-oh.
Uh-oh is right.
I don't like that. I have a box of 94
Aight.
crayons at home.
Why is that?
It's a W. It stands for whale.
Can you zoom in on the equation just so I can write it down?
It's
Yes,
for whale.
uh-huh.
Why is it persistent?
Very good.
Yes. Let's see who gets the more wrong answer.
Probably me.
I feel like I realized y are equal something.
Uh-huh.
I
Yeah.
can do it on
So-
both of my
Wait,
fingers.
is this y equals mx plus b? How is my, what is the minus?
No, because you have the x squared there.
You did?
Yeah.
So those are only for linear forms.
Oh.
All right, so here it is. We have 2.
I thought I told you. Because I'm an idiot.
Still, we're thinking about substitution, but notice both of them are equal to y. That's exactly how you want it. You want it to be both equal to y because we're going to substitute instead of equal to each other.
Wait, does that mean it to be negative 2x squared plus 2 equals 2 multiplied by everything else?
Absolutely. So what we,
That's so weird.
we're good. Technically, this is exactly what we're trying to do. We're trying to see when this equation, right, is equal to this equation, right? So when the substitution comes in, we're going to take this equation right here,
Set it equal.
set it equal to this guy. So we're still substituting. So negative 2x squared plus 2. So it's this equation coming around. 2x to the 4th minus 2x squared plus 1. I'm glad we learned all those factoring techniques. We might actually have to do P over Q. I'm not sure. I'm not sure if we do P over Q here. We might. We'll see.
We do synthetic division.
We could be doing, yep, synthetic division. We could be doing that. I'm not sure. Or on the homework, you might have to be do that.
Wait, I'm gonna do the division thing again. That was fun.
Okay, that's cool.
Can we do it?
Let's see. Let's see as we simplify this out. Let's see if we need to.
Oh my God, wait, I love the boxes. Dude, the boxes are so fun.
Let's see if my thing. Oh, that looks like a little minion.
Oh, okay. I see, let's see, I see 2 on one side and 2 on the other.
Add
If I do this, will it cancel these guys out? That's nice. Let's see, and then I'm going to,
Add 2x squared to both sides.
I go with that, add 2x squared. Okay, so we don't need to do the,
Have you met Maddie?
okay, there's that right there. Okay, talk to me. Who am I bothering yet? Oh,
Owen, Charlie, Tristan.
yeah, Dylan, still the Dylan. Dylan, what should we do?
Factor out. Just factor out 2x squared.
I'll go with that. 2x squared factored out leaves us with x squared minus 1. You know what? The only thing I don't like the 0 on the left-hand side.
But we can, oh yeah, put the 0.
Tristan? Go ahead. What would you like to do?
Yeah, Tristan.
7 more equal to 0.
Oh, yes. Awesome. We've learned.
Ah.
You can factor out the x squared minus 1.
Yes, this still factors out into x
Tristan,
plus
do you know what the
1.
word genius means? Because no, it's not you.
Also, when I graph anything working.
Unless your
And,
name's Albert Einstein, then sure, go ahead.
Isabel, what do we do here? We can,
Dude, same.
boom. Okay, this is cool. Okay,
So that's
going back to this here. So don't forget this one. Don't forget this one over here. We still have to solve this here. So divide by 2. Still 0, right? Take a square root, and the square root of 0 is still 0. Okay, so I got this one as 0.
1, negative 1, 0. That's so nice.
This one is negative 1 as I subtract 1, and this is positive 1. So I'm just gonna write 1. 1, boom. Okay, there's my 3 answers.
So x equals 0.
And negative 1 is 0.
That's interesting.
Worked out nice, right? Let's go back to, which one do you want to plug in, top or bottom? Which one looks easier to plug in?
Top.
Bottom,
Definitely.
We're gonna go with
bottom.
the top.
Feels like,
Look,
I don't want to read that.
you know exactly what it says.
Plug in negative 1 into the top. Let's see, negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. So 1, negative 1, 0. And here we're gonna, hey, you know what? Whenever you square something, positive or negative, it's gonna be the same thing anyways, right? So when you square a negative 1 or square a positive 1, you know they're gonna be, we call it symmetric. So you're gonna be adding the same thing anyways. Okay. Let's see, that's gonna be negative 2 plus 2, which is 0. Okay. So I got myself, okay, doom, doom, doom.
So wouldn't it be easier to just graph both of them and then like on a calculator and then just trace it to the points where they connect?
Sure, so let's do this here to answer Owen's question, because it's a legit question here. So what I want you guys to do, the reason I've chosen these homework assignments particularly for you guys, I want you to see the graph and the algebra connection, okay?
Okay.
Second is, when you do this in real life, you're not talking about 2 equations anymore. You're talking about at least 50, if not more. So at that point, you don't want to be graphing 50 equations.
Dave, I'm sorry if I hit you.
How sumptuous of you.
Technically,
I think it's still in real life, what happens, you guys use either a specific software or you crunch numbers in an Excel spreadsheet. You put in all your cost variables.
Where do we actually use this math in real life?
did you read the whole application?
Everything.
Yeah,
There's
there
an
was-
entire
there's-
application section,
Uh-huh.
business, watching 2 things happen at the same time, sports, nutrition.
Yeah, so
science.
here's my question.
You have to rephrase, where
Supply
are
and
you
demand.
going to? use
That's
this?
what I was gonna
The
say.
answer is.
Well, we don't know
Nowhere.
where you're going
No,
in your
okay.
life, Camille, so.
Got it.
I'm
So,
going
I
to
think-
just rob a bank, make a whole bunch of money and go move to like some weird island in the middle of the ocean.
Okay, so class, let's go with one more. One more that's gonna be a little bit even tougher than that. All yours for this
I don't want
one.
money because most people this classroom.
Yeah, but that's still something you would do.
No, I don't like old men. Ask Isobel from our Latin class. Isobel, did I like what's his bucket and the what's his story?
Oh my gosh, no.
I think it's really obvious.
No, she despises him.
I only like the 15-year-old that
Is that
has
something
chariot
on the
and was really
objector?
pretty.
That's just y plus 3x on the bottom.
Y,
Oh,
Y
no.
plus.
Oh, that's the
cursor.
cursor.
I was like,
That's the
it's weird,
cursor.
I haven't learned yet.
Yeah,
Cursor.
I thought it was an E for a second.
Yeah, I thought it was an E and I was like, why would you do this to us?
Oh, you can graph and utility.
Yes, okay, so let's see if we can do this. So if you have your calculators out, this one, whenever you get to e to the -2 or ln, remember ln, sometimes you can't solve for those, right? Notice, I do want to get this just stuck for a little bit here. If you were to plug in, notice one's already solved for, right? So if we did substitution method here, notice what's going to happen is we're going to have this right here, -4 e to the -x plus 3x plus 8 is equal to 0. Does that look solvable?
No. What do you?
That does not look solvable at all. We good?
But it probably can be.
Well,
Um,
can't you not do anything with
the-
the e's?
yeah, the issue here is notice you have an x that's in the exponent, then you also have an x that's on the outside. At that point, that's our dilemma. Because if you change forms, right, you're still gonna have an x that's stuck in the ln, and you have an x on the outside. So it's those little two pieces there, like I'm stuck both ways of doing this. And so at this point, Owen, you are true. Sometimes we do just go back to graphing. We try to make them simple as possible. We go to graphing. So 2 minutes left. Let's go with, let's see if we can, oh, sorry. Taskbar. Let me go here. Oh, that's right, yeah. We have 2 minutes left. Can I demonstrate real quick here? And then we can go from there. So we're gonna graph both of these. So on, clear, and go to y equals, and it's gonna be a -4. The E button is right here next to ln. So E button, ln, to the -x. Now careful the difference between a subtraction symbol and a negative symbol, right? We use the same symbol, but they totally mean different things. So -4 e to the -x. The other one's going to be, oh, bummer, hold on. I can't plug in that.
Wait, can you not plug in y equals -3x minus 8?
Because we have to have it set equal to Camille's right. We have to move things to the other side.
Camille's not allowed to be right. That, Owen said that.
Yeah, -3x minus 8.
Yeah, that's the one we want to plug in.
I found it.
Is it, wait, is
That's
it like
cool.
-0.6 or -6? Where they are.
Okay, this is -3x minus 8, and I think we should be out already by now. So let's go with it. If you want to click zoom and just kind of zoom standard, -10 to 10. Here's my first equation. It goes like this. My second equation goes like this. Oh, I think I see it right here.
Are you excited? You know, I'm so sorry.
And how we find it is we find it by something called like this right here called calc. And it's going to be the intersection point number 5.
Oh, that's useful.
Yeah, look at this. First equation, second equation.
Thank you.
Thank you, Mr. Money.
Yeah, we're good. Absolutely. Have a good weekend. See you guys on Monday as we review the test.
And it kind of works.
Thank you.
See you, Charlie. Have a good weekend, guys. I can send it to you. I'll send it to you guys today. And you have either the weekend or even through Monday to do it.
Have a good weekend.
You too. Thank you so much. Okay. So anytime you'd like to do it. If you give it to me by like middle of Sunday by 4 or 5 p.m., I could grade it and I could bring it Monday. If not, then I will just grade it and give it back to you on Wednesday. Something like that.
Great, thank you.
Good? Absolutely. Yeah. Let's see. When do you think you're gonna take it? Just in case, so I'll keep, you wanna take it today or tomorrow or Sunday during the weekend? Or do you think you're just gonna just brush it off, just do it next week?
Maybe during the weekend, maybe next week. Really depends on how, like, my catch-up work comes out, because I have a lot of it to do.
Sure, yeah, that's why I don't wanna push you into it as